Our second video dealing with rates of change and behavior of graphs, we're going to go through and just use a graph to determine where a function is increasing, decreasing, or constant. Use a graph to locate the local maximum, local minimum, and then use a graph to locate the absolute maximum and the absolute minimum. So there's a slight difference between the local max and the absolute max, and we'll go over all of that. All right, let's take a look at our first section here. So the first graph is just a function that's illustrated by the drawing there to the left-hand side. Determine the intervals over which the function is increasing and then when it is decreasing. You notice there is no area here where it's constant. If it was constant, we would have just a horizontal line. So increasing. So I deal with everything along the x-axis when we do these. So for talking about increasing and decreasing. So as I look across this way, what is the function doing? All right, so here at -1, the function is moving from lower position to upper position until it hits this turning point. This turning point is here at 1. So between these 2 points here and here, the graph is increasing. I'm moving from 2 on the y-axis to 3 on the y-axis, so that means it's increasing. So we've got two different things that we want to write here. So when are we increasing, over what intervals, and when are we decreasing? Now, it's a lot easier to do the increasing, decreasing when we use interval notation. So when we're talking about increasing, decreasing, we're talking about what is it doing between these two values. So if I'm using interval notation, I need to know, am I going to use the bracket because it's included? All right, so when I have a bracket, it's included, or do I use the paren because it is excluded from the set? All right, so that particular location is either included or excluded. All right, when we deal with these, we are talking about in between this point and this point, because at that point it is neither increasing nor decreasing, it's changing its direction. So when we talk about whether it's increasing here, we are increasing over the interval from -1 to 1. They will always be parentheses when dealing with increasing or decreasing. Okay? So now we look at the next interval. So here's my turning point, and I look to where the next turning point is. The next turning point's there. My graph goes from, what did I say, 3 all the way down to -1. So then that means this is a decreasing interval. So between the points 1 and 2 on the x-axis, this graph is decreasing in value. So again, we do not include them. So 1 to 2. Then I have the next interval from the turning points here out to here. And I go from -1 on the y value up to a +2. So then this is increasing because everything goes from left to right. So even if I had arrows at the end of these, which if there was such a thing, if I had an arrow here, it doesn't mean that this is going down. It might be moving down if I'm going to the left-hand side, but that is not what we're doing here. We're not looking at the arrows. We are only paying attention to what's happening as we move from left to right on the x-axis. So then our last interval is right here, going from this point up to here. This function is increasing over the domain from 2 to 4. So we are increasing from 2 to 4. All right, let's try another one. All right, so this particular example, we've got another graph, but we're being asked to find the local maximum and local minimum values, and then go ahead and determine when the function is increasing and decreasing, and write the intervals over which it does so. So in this particular graph, you can notice that we have the arrows at the end, which means that this is continuous, is going to keep going past what our graph window allows, which is fine. So let's start dealing with the fact that, all right, so I got my local max that we're going to go through and find. We're going to have a couple points there. We're going to have our local minimum. We're going to have to figure out when is this function increasing and when is this function decreasing? All right, so hopefully my little mug down here in the corner doesn't get in the way. Let's take a look at the points. So this is one of my points where I'm turning. This is another point where we turn. Here's another turning point, and here's another turning point. So it's kind of understandable what a maximum is, right? I mean, we should know that already. So this would be a maximum point, and this would be a maximum point. These two at the lower points would be our minimum and another local minimum. We have no absolute maximum and no absolute minimum because of the fact we have the arrows at the end. So there's no absolute maximum, we go forever. There's no absolute minimum because we go forever. So let's pick our points for the local max. So we've already talked about this point. We are located at a -2 and a +3. Our other point is a +1 and +2. So there are our local maxes. Our minimums, we come this way back 1 and we don't move up and down on the y-axis, so therefore we are at -1, 0. And then we need to find the next one, which is over here at 2 on the x-axis and down 1 on the y-axis, so 2, -1. The interval over which this is increasing, remember from the last example I said we are always moving this way across the x-axis. So if I'm coming over from way back here and I'm moving my way this way, my function is increasing all the way until I get to here. Then it is no longer increasing, it is not decreasing yet, it is turning. So when are we increasing? Well, it would start out at -infinity, and then it would continue until we hit our first local max, which is an x value of, -2. Then we go from our next turning point to the next turning point, and now from here, this is a decreasing function, again, going left to right. I'm going to say that so many times. All right, so it's going from left to right, and I have my maximum here, my minimum here, so that means it's decreasing. So I decrease over the interval, in this case, only from -2 to -1. Then going from left to right, we're dealing with where is it increasing in this case. So we're going from a -1 to a +1. So we're back up here at the increasing, -1 to +1. Then we're decreasing again, going from left to right. So in this case, we're decreasing from 1 to 2. And then finally, we're going from this turning point left to right until we hit, well, we're not going to hit it. We're going to hit infinity, okay? So since you can never attain that, that's why, remember that we use parentheses again. So I'm going to go from 2 to a +infinity because we can never get to infinity, so we would always use that anyway. Okay, take a look at the last one. This one should look familiar. This is the same problem that we dealt with before, but it has slightly different questioning here. The graph shows the population in a small industrial city, again from 1950 to 2000. Variable x represents the years from 1950. Determine the intervals on which the function p is increasing. What was the maximum population, and in what year was it attained? All right, so I'm looking for the maximum based on these intervals that they gave us from 1950 to 2000. I can see that right here, this is going to be my max. And it's all they're asking for in that particular part. Okay, and I got to figure out about what year it was attained. So, it looks like right about there. So 25 years after. Determine the intervals on which the function is increasing. So if I look from here to here, the population increased. Here to here, it's starting to decline. All right, so let's see, increase. And this is when it's actually an applicable scenario for any of the mathematics that we're doing in the pre-calculus. You need to have the actual representations when this would be useful. So looking at the increase, so the population of this town was increasing, or city rather, industrial city, this population was increasing from 1950 to, let's see, that would be 1975. So if we're talking about it as an interval, we're going to go from 0 to 25. What does that mean in reality? It means from 1950 to 1975, we had a population increase. We had a decrease, according to this graph that we have here, from year 25 all the way up to year 50. So what does that mean in reality? That from 1975 to the year 2000, there was a population decrease. All right, so how could this even be useful? I mean, who cares? So we had a population increase, population decrease. If you're trying to figure out for your city tax bases, what do I need to do to get more people into our town? Do I need to build this new school, because it looks like our population is decreasing? These are the kind of things that you would pay attention. You're paying attention for trends. So the maximum population looks like right here. So max pop is, let's see, it asks for what is the maximum population. So 50,000 residents in the year not 57. Okay, try that again. So in 1975. Okay. All right. So, and this is all coming off of just a simple graph. All right, what's the maximum population? Maximum population of 50,000 people, and it happened in the year of 1975. But they've had a kind of a drop-off period since then, up until 2000. All right, so again, one more done under our belts. Again, this is Robert Bain. Adios. Have a nice day. Hope this was helpful.